So, hello student. Once again, we are here to discuss about a new topic which is called sorting, and we will be doing this sorting introduction with the help of arrays. So, let's begin with the topic of sorting. Sorting refers to the operation of rearranging the contents of A, where A is an array of elements such as A1, A2, A3 up to AN in memory, so that they are in increasing order, numerically or lexicographically, such that A1 is less than A2, A2 is less than A3, and so on till AN. Now let's suppose we understand this definition with the help of a simple example. Suppose an array data contains 8 elements as follows. The first element is 77, 33, 44, 11, 8, 22, 66, and 55. And we want to arrange them in numerical order. So after doing the sorting operation, we will get a sorted array like this. Like we are having a minimum element 11 and a maximum element 8, 88. So we have sorted the complete data list in lexicographical order. The complexity of a sorting algorithm measures the running time as function of number of items to be sorted. We have already seen what complexity is, and we have seen that the complexity largely depends upon the number of items. So each sorting algorithm will be made up of some operations. What are the operations? We will see shortly. When the elements A1, A2, A3, and AN are to be sorted, and B as an auxiliary location, right? We want to sort either the items or the item within auxiliary locations. Now let us see what are the operations that can be performed while we do sorting. The first operation is called comparisons. It tests whether AI is less than AJ or whether AI is less than a auxiliary location B. So if we are doing comparisons, we want to make sure which data item is less and which data item is more. So then I can sort these two in a numerical order. The second basic operation, what we do in sorting, is called interchanges. It switches the content of A and AJ or AI or and B, right? So it changes the content of the two data elements, right? After doing comparison, if I find this AI is less than AJ or AI is more than AJ, I may, depending upon some condition, I may interchange these two values and to make them sorted. The third operation is assignments, right? It sets B value of B to an index value like AI and then sets AJ to B or AJ to AI. We have seen such swapping or assignment operations in our example of swapping two numbers that we have already done and you must have done in your C labs. So what is happening is we are using these three type of operations while we implement the concept of sorting. Normally, the complexity function measures only a number of comparisons since the number of operations is at most a constant factor of the number of comparisons, right? That means the complexity largely depend upon the number of comparisons we make, right? Number of interchanges and number of assignments in comparison to a like in relation to a comparison type operation are generally constant in numbers, right? So our complexity of an any algorithm will largely depend upon how many comparisons it makes for sorting a particular array. Now, in the next section, we are going to see some basic algorithms or like bubble sort, insertion sort, and selection sort. Right? So that's all for this video lecture. Thank you and have a nice day.